Om Shahana Bhavatu Shahano Bhunaktu Shahu Bidjang Karuvabhai Tejasvina Bodhi Tamastu Ma Vidvishabhai. Om Shanti Shanti Shanti. Ishani, now you are host, so you can start.
Sir, please make me host.
So,
So please make Anindita the host. Yes, sir.
So Ishani, please you make Anindita.
Yeah, sure, sir.
Thank you, Ishani ma'am.
Yes, Anindita, you are the host now.
Okay. So we're just going to, again, as I said, we're going to recap what we saw yesterday. And we're going to go ahead with what we are going to discuss after that. So we were talking about 3 types of validity yesterday, right? And 2 of them after that were subtypes. So we were talking about content, face validity, and then we started talking about construct validity, where we discussed about convergent and divergent validity. Yes, I think that is what we're following along with.
Yes, yes.
Okay, let me just share the slide that I've already been so that we can go ahead with recapping. So when we talk about types of validity, we've talked about content validity, face validity, and construct validity. The only type we have left is a criterion related validity, under which we have 2 subtypes. So let's start from the beginning. So let's say we're talking about content validity now. So you have an idea already, right, Darren, about what content validity is?
Yes, yes.
So it is essentially whether your test is going to measure what it's supposed to based on the content of the items. Yes?
Yes, yes.
So if you look into the definition of face validity here, it seems very similar, no? It's talking about how whether a test appears to measure what it's supposed to.
Yeah.
So what makes the difference between these 2? What do you think?
It is more what it appears to measure. At first glance, face validity is like more, it's like what it appears to measure when we read the items in a first glance.
Yeah.
The temper of the test, the nature of the test.
Yeah. Yeah. So if this is face validity, how can we differentiate content validity?
Differentiate with?
From face validity. Face validity is just what it appears to be. Then what is content validity?
Content is more analyzing it in the questionnaires in a deeper form.
Okay, I'll take that. Thank you for that. So building on to this, I just want to add a few more points with regard to the difference. When we say content validity, we're going to see each and every item and whether it is going to form whatever construct you're trying to measure. So whichever concept you have in mind, let's take the same example that we here in our slide, right? So if we are going to take this example of a final exam at the end of the semester for statistics course, if we were to determine the content validity, we will have to go into the details of it, whether each of it is covering whatever is there in the syllabus. So we will have certain criteria to cover the syllabus, right? Usually when you're setting question papers, we'll have certain weightage for certain units. So according to that, we will set the question paper. Content validity is where you're checking whether your items are covering the weightage required for the unit. Face validity, however, is a more casual way of going about it. You're just going to briefly skim through the questions and see whether it is statistics based. That's all. So content validity is a little bit more formal, where you're going to give it to an expert. They're going to verify whether it is measuring the concept that you want. And face validity is where it is a little bit more informal. You're just going to see whether overall, if you skim through it, does it seem to measure what it's supposed to? Does that make sense?
Yes, yes.
Awesome. So this is the very slight difference between face validity and the content validity. Although we are looking at the content of the items in both these types of validity, the level to which you're going to look into these items differs between content and face validity. Content validity is going to be a little bit more formal, whereas face validity is going to be a little bit more informal, just by the appearance. So when we talk about face validity, it can also be about the structure of the question. It can be generally about how the rating scale is going to be and things like that as well. Whereas in content, you're going to look into the writing of the items, right? So this is what we're seeing as the difference between these two. And yesterday we also saw about our construct validity, under which we took into account the two subtypes, which is convergent validity and divergent validity. We looked into all of these definitions yesterday. So can you tell me what is the difference between convergent and divergent validity?
Convergent validity is we are comparing and some other already existing test and with the test what we have designed and seeing how much it is matching.
Exactly. So what is divergent?
How much it is differentiated from the existing test. That might maybe checking something else where it's the same example what we saw, right? Depression and anger. I'll be more concentrating on anger, and wherein that it says it will be going on depression, but the base is still same for some extent.
Absolutely. I'm glad you're here, Prasanna sir. Welcome.
Oh, sorry, I was late because last 36 hours there is no internet. So
I
mobile is driving
understand
fast. I'm charging mobile and again joining calls.
Of course, I understand. That's all right. I'm glad you're here at least right now to begin with the discussion. We just started, so I'm just going to summarize a little for you so that you can catch up on what we've talked so far. So convergent and divergent validity, this is the difference. You've got it right. We were talking about the difference between content validity and face validity. So what do you think is the difference between content and face validity?
No, I think you are mentioning, right? The content is more of the type of the question or the nature of the question. Whereas in face validity is on that level that how that question is being validated or evaluated, like the way the choice has been given.
Yeah. That's one way in which we can differentiate content and face validity. But in common with an overall understanding, what we can see is that content validity is more towards an expert reviewing the content of your items. Whereas face validity is a more informal way where you just get somebody to look at the brush through the items and see whether it is actually measuring what it's supposed to. Just a very informal way of doing it is face validity. When you're formally doing it, is called content validity. And one more point that I want to emphasize here is that when we talk about content validity, I just gave an example to Dharani as well, where we were talking about certain question paper constructions will usually have weightage towards certain units. So therefore, we'll have to set, let's say, 3 questions towards one unit and 2 questions toward the next unit and so on. So if we are checking this, then it comes under content validity. But if you're just going to look through the questions and whether it is about that particular subject, that is face validity. Does that make sense, sir?
So it's a kind of a vocabulary meaning, like a face value and what is the inside the content kind of, is it right?
Yeah, content validity is a little bit more in-depth than just face value. That's all.
Okay.
So I just wanted to let you all know about the nuance and the difference, because this is very important for us to be able to differentiate what kind of validity it is. And just another pointer here, face validity is one of the weakest form of validity that is available, because it does not really give us any other insight rather than this is measuring appearance wise what it's supposed to measure, it's measuring. That's all we can conclude from face validity. So we cannot just go ahead with the face valid tool. We need to go into other types of validity if we're going to standardize a particular tool. So moving to what we're talking about, construct validity. We talked about convergent and divergent validity, where you were right. Convergent validity talks about how much this test is agreeing with the previously validated test for the same variable. So for the same tool, whichever variable that you're choosing, the tool that you've constructed will be compared with an already existing tool for the same variable. And if you are seeing a really good correlation between the two, then it is a convergent valid tool. When we say divergent valid, we're trying to differentiate how much our tool is different from what it is not. So we already discussed an example in the previous class as well. So we're just going to go ahead with that. So now we're going to talk about the next type of validity, which is our criterion related validity. So criterion related validity is one of the most important types of validity, under which we have two subtypes. We're going to look into it in a little bit. So when I say criterion related validity, what I'm saying here is that we are checking whether this is measuring a criterion in either a concurrent manner or a predictive manner. So these are the two types of criterion related validity, which is concurrent and predictive. So according to Anastasi, the writer of the book Psychological Testing, we can see that her definition of criterion validity is that it indicates the effectiveness of a test in predicting an individual's behavior in specific situations. So how far are we able to predict the behavior at the time of giving the test and in the future of the same subject for a particular criterion is what we're going to see under criterion related validity. So when we say concurrent, it is at the same time, and when we say predictive, it's in the future. So these are the two things that we need to keep in mind. We'll get into the details in a little bit. So here we have an example given in the slide. A mechanical aptitude test. The criterion might be subsequent job performance as a mechanist. Right? So for which we can have an aptitude test that will measure this particular performance as well. So this test can predict the job performance as a mechanist. That is something we can see as a predictor. So when we talk about criterion related validity, we're essentially talking about prediction of your subject getting particular performance or a particular score in the future or in another test at the same time. So these are the two things that we're going to talk about. So under this, we're now going to talk about the first type, which is the concurrent validity. Concurrent validity, as I just said, it talks about their score at the same time. It is not going to talk about a score in the future or any other time. So what we're going to see here is if you have a tool and it is going to be compared with scores of another already existing tool, then we can say that there is concurrent validity present, right? So one thing I want you all to please pay attention to and think about is the difference between convergent validity and concurrent validity. So even in concurrent validity, as you're looking in the slide here, concurrent validity is where you're going to correlate the tool that you've constructed with the measure that's been previously validated already. So if you are checking for a depression tool, you're constructing a tool for depression, let's say, you're going to check this with BDI, let's say, at the same time. So if there's a good correlation, you're going to get concurrent validity. If you're talking about convergent validity, it is also very similar in the sense. So how do we differentiate between convergent validity and concurrent validity? What do you think is the difference?
between the concurrent validity and convergent validity.
Yeah, yeah. There's a very giveaway sentence in the slide. If you can find it, that will be possible.
Is it the coefficient of the correlation?
Both are correlation coefficients. Sir. That's the point.
Hmm.
Yeah, it is. It both measures. We compare both. In both the cases, we compare with the previous measure.
Yeah, yeah. In both the cases, we're going to use another measure that's already been standardized. We're going to get a correlation between your constructed tool and the previously standardized test. That's the same procedure for both convergent and concurrent. So what is the difference if we're talking about here?
That maybe the time in which we administer.
Both of it is going to be done at the same time, no? Then how can we go ahead and find the samples again for the same test? It's kind of difficult if you don't have a plan to do that already. Can I give you a clue?
Yeah.
That's
Yeah,
the
yeah.
clue.
Okay, predicting the
Exactly.
other output.
So the interpretation of the values changes between convergent validity and concurrent validity. When we say convergent validity, we're going to say there's high correlation, therefore my tool is measuring the same variable as the other tool that has already been standardized that variable. It stops with that. But when we say concurrent validity, when we test it out with other tools that are going to measure the same variable, we're gathering data so that we can say if I'm going to use this variable is going to be predicted in this tool as well. So if I'm getting a score of this in my tool, then this person is more likely to get a score on that tool in this way. So if you're able to predict it in that way, that becomes concurrent validity. At the same time, if you're using these two scores to predict how this performance will be at this moment, then it becomes concurrent validity.
Can you
Are you
give
able
an
to follow
example?
along?
Like, can you give an example with a variable?
Yeah, let's just take depression scale, right? Let's just take BDI because we already know BDI very familiarly. So let's say I'm going to construct a tool for depression, right? So I'm going to test it out with BDI as the validated tool here. So if I'm getting a score of, let's say, let's take my total score is going to be 50, just hypothetically speaking. And my individual, this one subject is getting a score of 10 out of 50 in my tool, right? And
Okay.
at the same time, if I'm administering BDI to this individual, let's say they're getting a score of around 8 out of the entire thing, right? So if I'm able to say that this score is what I'm getting in my tool, if this is the score in my tool, then they are more likely to get an 8 on the BDI scale. If I administer it, then that is concurrent validity. I've gathered the data now that if in my tool this individual is getting a 10, they are more likely to get an 8 in the BDI because correlation is high, let's say.
So if it is 10 here, it will be 8 there, or if it is 11 here, it will be 9 there, like that.
Exactly. So I will first gather the evidence that whenever I'm using these kind of tools, I'm getting such a correlation. So if I'm having very high correlation between my tool and BDI, I will be able to make such predictions saying if a person is scoring 10 on my tool and they are scoring 8 on the BDI based on my evidence that I've gathered through correlation, I will be able to say for any other future testing, if I'm going to administer my test, if my person is going to score 10, I can say that they will score an 8 on BDI.
But for that,
without even testing.
But for that, we will need a, it is kind of like a regression.
Yes, essentially, yeah.
For that, we need a large sample size. Sir.
Yes, we do need a large sample size. We also need multiple tools to test it with so that we can gather enough data. So that is one thing that we need to consider when we're talking about concurrent validity. Okay, but this is one of the better kinds of validity because it gives you a reliable measure on how much we can trust this tool to be able to predict the same variable in other tools as well.
Okay,
Right?
okay.
So if your tool is not, let's say, a clinically measuring tool, but you are able to see that such scores on your tool gives clinically measurable depression on VDI, then this can be used to correlate your scores and maybe use it for future understanding of your subjects or anything else. Right? You need not limit it with just your limitations of your tool because you've now gathered evidence that certain scores in your tool are going to be clinically diagnosable as symptoms because you've administered VDI along with it and you've gathered data.
Okay.
Does that make sense?
Yeah, yeah.
Awesome. Any questions on this?
No.
So when you say
Yeah.
predicting,
Yeah.
okay, the projection, okay,
Mm,
basically extrapolation
yes.
of the what is there. So
Exactly.
what will be the base? Would it the BDA outcome is the base or your one is the base?
Both of it together. The correlation is the base.
No, you explain when mine is having this, that is having like this, right?
Mm,
So one of them is getting extrapolated,
mm,
correct? So
yes.
which which measure is getting considered as a base to start with, so that when you do extrapolation, I know that other one is giving this outcome, or like we
Yeah,
don't.
so your tool will be the base yourself because you want to determine the concurrent validity of your tool. So therefore, your score will be extrapolated to the other already valid tool.
Okay, the next question here is if we need to say extrapolated, will we
Hmm.
leverage that other tool on our sample, or we don't bother about it? We just extrapolate the value.
We are going to administer the other tool initially so that we can gather the data so that when we are administering our tool in the future, we'll be able to say this is what the equivalent score in the other validated tool will be.
Okay.
So we will gather the data already so that in future, if you're going to validate our tool and say, this is a really good tool, we can use it for any standardized purposes, then we'll be able to say if an individual is scoring this much, then they will score this much on VDI. Therefore, this is something we can consider for maybe clinical purposes.
Okay.
I think that you're not convinced. We can discuss this further.
No, I'll take
in a
it
little
because
bit.
see, the moment it goes to prediction, right?
Mhm.
The predictions doesn't come on the air, right? So if you have both the values, then what is predicted in this? See, if you give the both
That is the thing, sir. That's what I'm trying to say here. So when I say both the values is something that we have, considering both the values, we are gathering the data of correlation coefficient. We need to understand the correlation coefficient to be able to say that my tool will predict such a score in the other tool. So we need to understand how much my tool and the other tool is correlated between each other. So we're gathering that data first. And then for the future, we need to have regression model or whatever we are using to understand if this individual is scoring this much, how much will they score in the other group.
Okay, so in that case, is it right to say that the validity, what we are doing here is, if I give this test to the same sample, what is the outcome is coming, and if I use this same test in future, okay,
Yes.
considering BDA as another base or something like that.
Yes.
So this is what I would, maybe today I would get 3 or 4, maybe it will be improved to 4 or it will downgrade to 1. That is what you are trying to achieve.
Yes.
Okay.
All right. I hope that made sense to extent. I know there's a lot to process when we talk about validity. We can process that slowly. You can take your time with that. There's nothing wrong with it. So this is about your concurrent validity. Then the next thing we're going to talk about is our predictive validity. Predictive validity is the little bit different from concurrent validity, but a little bit more, what can we say, nuanced, right? So when we look at the slide here, I'm just going to read out what's there so that we can be on the same page in the beginning, and then we can have all these examples and extrapolations of information. So predictive validity is the extent to which a score on a scale predicts the score on some criterion measure. Please note the point. It is the extent to which a score on a scale or a test predicts the score on some criterion measure. Right? So here when we talk about prediction, we're not looking at the same variable, but we're looking at another one. So what can you think of when I say this statement? We're not looking at predicting the same variable as in concurrent validity. We're looking at predicting another one, some criterion measure.
Is a criterion which helps you to predict a value, right? So suppose what is the age impact on salary or something? Is it something like that? Or
Not exactly age. Hold a thought on age, sir. We are going to talk about it today as well. We'll get to that. But when we're talking about criterion measure, we're talking about another variable here. I'm just going to roll here so that we can read up on the example and you can come up with your own example so that you can get a better understanding.
okay. So it's like you gather the information and after few go past the time and again get that whatever happens, then compare test two.
Exactly. But what are you comparing here to? So when we take the first example, our first variable is this, but our second variable is performance. So these are two different variables. Yes. So that is the catch of predictive validity. We're trying to predict these scores of average performance based on a mechanical aptitude test that was done before.
If the test is common for both the thing.
No.
Example. Okay.
No.
So it doesn't matter
We
what
have,
test you are doing.
yeah. We have had only one mechanical aptitude test for a sample. And we've gotten their scores. We're trying to see whether higher mechanical aptitude tests can predict higher average performance for these people after a year or two.
Okay, I think the classic example here is the JEE NEET outcome will be compared after 2 years with what is happening in the course. And
Exactly.
See what is
Exactly. You're on point. So that is predictive validity because we are using one tool to predict the performance of this individual on another variable in the future. So if I gather such data and if I'm able to get correlation for such data, what I'm going to be able to say is if a person gets, let's say 80 on 100 in mechanical aptitude test, I will be able to say that their performance will be above average or even high in the future. Does that make sense?
What is the outcome of this validity? Like, are we saying that is that mechanical aptitude? Let's assume this way, right? A mechanical aptitude test. The persons who got 80 plus or 90 plus, they are not scoring well. Are we saying that the aptitude test has to be improvised or something else? What is the outcome of this kind of validity?
The point of this validity is that we're trying to make sure that your tool is applicable to some outcome in the field that you wanted to measure. For example, if I'm saying that, let's say we are taking into account test anxiety, and I'm developing a tool for test anxiety, right? So if I'm going to say that people low on test anxiety in my tool right now are able to handle their final semester exams better, let's say, for example, right? I've established a correlation like that because I've gathered my data and I'm able to say that there is a significant higher performance in their end semester because for those who have scored low on my test anxiety scale. So what I can do is I will now get an understanding that whoever is going to score high on my test anxiety scale is likely to have a poorer performance in their end semester exams. Therefore, I can aim my intervention accordingly so that I can make the change. So my validity is going to help me understand where I need to manipulate my independent variable so as to make a change. Does that make sense?
Little lost. When you say
Okay.
the outcome is okay, let's take your second example, right? So you scored high and they got it low in the final semester exam. So are we saying, okay, hey, I don't know how to state the statement, right? So there's independent variable which is driving that result, the fourth semester or eighth semester result. What we are saying is we need to control it in better way so that your results will not get impacted. Is it what you are trying to say?
We're not going to say we need to control it better. We can give interventions in such a way that our desired results are amplified.
Okay.
So let's take the same example of an entrance exam, right? Let's even take recruitment, for example. If you're going to give an aptitude test to a bunch of trainees who are going to be potential recruits, and we get certain scores out of it, our understanding will be that if we are able to correlate their job performance after 2 months or 3 months, let's say during the first appraisal, let's take that for example. So if we are able to do a study that helps us correlate between their entrance test scores and their first performance appraisal, and we are able to find that those who have scored high on the entrance test are able to get really good performance appraisal in the first time, then we're going to ensure that our recruitment is going to be directed in such a way that our recruits are going to be purely based on those who score high on the aptitude test, because our end goal is to make sure the productivity increases. Right? So we can ensure that the outcome of whatever we want out of the tool will be a desired outcome based on how we're going to manipulate the independent variable.
Okay, got it. Wish it's all been implemented in corporates.
So it is basically predicting.
Yeah, Dharni.
So it is basically predicting a larger outcome or a larger variable using a small component,
Exactly.
smaller variable.
Absolutely. So if you're familiar with regression models, if you're familiar with median and mediating variable, mediating variable, predicting variable, and so on, this will be a very easy concept to make sense. So that's just something that if you want to get a better hold on this predictive and concurrent validity, I encourage you to read up on that a little bit if you're interested. Otherwise, this basic information is enough. I hope we are on the same page so far.
Yeah.
Asana sir?
Let's move on. Last point I'm still digesting. Move on. Let's move on.
Okay. Then the next thing you will have a little bit more tougher experience digesting, I think. So with this, we are completing the basic types of validity, right? So I'm just going to stop my screen sharing for a little bit and share another type of validity that you should be familiar with, which is the differential validity. So here is where I asked you to hold your thought, Krishna sir, the thought on age, right? So I'm just going to define differential validity so that we can talk about how this age factor comes into play. So when we define differential validity, it is essentially the difference between one subgroup and the other that we are seeing based on the correlation value, right? So when you said age groups, this is what came to my mind as an example. So if we are going to take an intelligence test, right, the capability of even a performance intelligence test, let's say, for example, Raven's progressive matrices, very easy for us to all understand. So Raven's progressive matrices, let's say, we have subtests from A all through E, right? So each of these subtests are increasing in difficulty, right? For RPM, They all have the same method of answering. They all have the same question type, but the difficulty increases across the set A to set E. This is the entire structure of RPM, Raven's progressive matrices. So when we take this into account and we're administering to a population of varying ages, right? So what we're going to get as a result is that very young people are not going to be able to answer even items in set A, which is the easiest item. And some old people will be able to complete entirety of set E also. Yes.
Okay.
So this is the difference that is caused purely due to the age capability, right? When a young children are administered these kind of tests, what we can clearly see is that the difficulty level is the hindrance for them when we are trying to measure intelligence. So it is not that they don't have the intelligence, but that this is beyond their cognitive capacity, right? We cannot give them something that is beyond their cognitive capacity and say they are not intelligent. So therefore, this difference comes in when we're talking about our scoring and norms as well, right? We have completely different scores for different ages when we say Raven's progressive matrices.
Okay.
So therefore, this kind of age norm is helping us with differential validity. Because if an individual is of a particular age and they're getting a particular score, our interpretation will be very, very unique to that particular age group, right? For a person of, let's say, 10 years old, scoring an 8 on RPM, and for a person of the age of 26, scoring an 8 on RPM, have completely different interpretations, right?
Yeah.
So this difference in the way that we are going to talk about the scores that is determined by the nature of the subgroup is called differential validity. Does that make sense?
Okay, but is it only applicable when the scale has two versions? Or
Not necessarily. Not necessarily. This is going to give us an idea of how much we can modify the tool in order to minimize these differences as well. Right? For example, let's take a tool that is differentiating between males and females on the variable. Right? So if we are getting a tool for which we can go ahead and give male and female forms, that's fine. That's up to you. But if you don't want to do that, what we can do is we can pick those items that do not give the significant correlation differences between male and females. Right? And that will give us one neutral form overall. Does that make sense?
yeah.
So
yes, sir.
technically, differential validity can apply for it if you have two separate samples, right? So independent samples.
Yeah.
So that means that comes into the picture, differential validity.
Yes. So this subgroup can be based on anything, right? Subgroup can be based on age. It can be based on socioeconomic status. It can be male and female. It can be based on geographic details. It can be based on caste, religion, anything that can divide a group into different subgroups. We can calculate something called the differential validity. Because based on this differential validity, we're going to try and understand how our norms are going to change. Does that make sense?
You got the point.
I think the practical application when
sorry,
yes,
go ahead.
No, please go ahead.
Do we have any matrices or the mapping of this when we use which validity? Or I need to plot it out myself.
I think I will deliver that to you in our next class. We have 10 minutes. I just want to recap this entire thing right now.
Okay. No, if it is there,
in the next class, that's all right. That's all right. What you asked absolutely makes sense. Giving a map will register things in your head. I absolutely agree. So I will try and get that done for next class. In the next class, we're going to have another academic assistant, Anushree ma'am. She is going to help us with a practical understanding of this differential validity. Okay, she's going to have some data that's been differentiated based on caste or if she's getting newer set of data as well, that's all right. So she's going to help us understand how to calculate this difference and what this difference implies for our sample and our tool. So she's going to help us understand that, for which this is the theoretical basis.
Okay.
So these are just a few examples of where our differential validity can help, because as I said, based on the differential validity, this can help us understand the norms that we can develop for the particular group. If you look at the second example here, this one, you can see that when the test, an aptitude test was taken by Americans, they have a correlation coefficient of 0.59. And when it was administered to Hispanics, then their correlation value was 0.40 only. So you can clearly see that the test has higher validity, higher correlation coefficient for Americans than for Hispanics, which means we may have to separate out the test items based on culture, right? So what we say with this difference and how we word this difference is that this validity coefficient shows that there is a bias towards Americans. So this difference exists based on the bias towards Americans, because it is an item that the Americans are able to answer better than the Hispanics. Does that make sense?
Yes.
Awesome. We just had a chorus of yes. I really appreciate that. So this is essentially what we're trying to do with regard to differential validity, because this sometimes gives us an idea of how to separate out the tools so that this difference is captured to the accurate amount, or it can help us reduce this difference so that we can get a common tool for all the groups, all the subgroups involved. So this is up to how we are going to take the next step forward, right? But this will help us take the decision on how to go about it. Does that make sense so far? Yeah, okay. So in short, we can just take this into account. Validity is prediction, whereas differential validity is differential prediction, where we are trying to predict the differences between the subgroups as well, right? Any questions so far? Would you like to take the 10 minutes to process more information?
So, in a practical situation,
Mhm.
between reliability and validity, validity is heavily driven by statistical models, or both reliability and validity we have to drive it through only statistical models.
It's recommended that we use statistical methodology because it is easier for us to be able to control these differences that are otherwise difficult for us to control.
Okay.
So it's recommended that we look into statistical models because certain things, for example, like demographic details, these age groups, and the normality, if we are unable to exactly get these values right because of our, let's say, sampling methodology or the nature of our population, we have to control for it based on statistics. So if we are going to already adopt a statistical model, we are already controlling it in the process of our calculation. So that's the advantage of using statistical models.
Oh, that is fine, Nandita. My question here is, see, the last few weeks, what we spoke about reliability and validity, right? I kind of in the context saying that on validity, we are giving a lot of stress on prove this statistically, bring correlation and everything. Wherein in reliability, I really don't see much statistics playing a dominant role. Other than a few here and there, you guys spoke about it. So what I wanted to understand here is it reliable? Just is going taken care by that Quran bench or whatever the case, right? Between this something like that, I don't know. I may be confused like that. But wherein here I see that every validity has to be either correlated or has to be tested against with the statistical model. Then only I can say that, which is again valid.
Yes,
Okay.
of course.
But reliability, I'm just losing the context now after going through this validity first. So reliability, just to make sure that can it trust your test or not?
Exactly. So reliability is just to ensure that, okay, what I say makes sense and everybody's understanding it the same way in the n number of times that I may administer this test. So if you're understanding my question one way in this particular moment, if I give you the same question in the future, you're still going to understand it in the same way. That is understood through reliability because you're going to get a consistent score out of it. Validity is going to talk about whether this particular item is going to give us the measure of the variable that we want to, right? So both of it together will only determine the standardization of a test. So we'll need to say that, okay, this person is going to understand it the same way, and this item is also measuring the variable that we want to. So the simplest way for reliability is through correlation and Cronbach's alpha and KR20, right? So these are the internal consistency as well as the easy test, free test, and other models that we've already talked about. So coefficient is the coefficient of correlation. I apologize. Correlation coefficient is the biggest predictor when we talk about reliability. All we need is the correlation. We can easily talk about the nature of the correlation between one test and the other easily. Here in validity also, we are using the same correlation as the coefficient for validity. But our understanding and the way we are understanding it is a little bit toward the content and the nature of the items rather than the consistency of the items. That's all.
So in a way, maybe I'm overstepping in this statement. Can we
That's
say
all.
that whatever just now we spoke about, the predictive validity, it is kind of aligning what we are trying to achieve through reliability, right?
Exactly. That's the understatement that we are not essentially talking a lot about. Because when we say reliable tool, it is not essentially valid. But most valid tools are likely to be reliable. We still need to test for it because we don't know how much of reliability we can expect. But they are most likely to be reliable if we're getting a high validity.
Okay.
Any other questions?
Did you drop that first book? There are 3 books you dropped in that Google Classroom, right? The first book I said
Yeah.
it was not available. Did you drop
Yeah,
it
yeah.
back?
I've activated that again. Please try and access
Okay.
that issue. You should be able to access that now.
Okay, got it.
Yeah.
So again, kind
Yeah.
of after 2 decades, I'm coming back to academic. So somebody is doing a research, okay, like a PhD scholar or somebody like that, they are doing that. So in a real scenario, this kind of things been taken care if they tend to prove something new to the domain. Is it how this is how it happens, or it's like still?
Yeah.
Because I see more of a theoretical concept, but or the Anushri is going to explain me about this, how practically is being done, something like that.
We're just going to get in the same way we did reliability and the same way we did the item analysis, the same way Anushri ma'am will also teach us the differential validity. But the thing that I want to emphasize here is, I think Dharani can back me up on this as well, that there is all of this information that is needed if you're going to construct a tool for your PhD thesis. You will be going through pilot testing, you will be going through multiple versions of the tool again and again, and do multiple studies to establish all of this reliability, validity, and so on. It is an extensive process, but you will get a very good tool at the end of it. So a lot of people are motivated to do that.
Okay, got it. Because my mind is again and again going to our synopsis only, my project only, Andita. Because I'm trying to define something.
Of course.
Okay, industry doesn't have the very standard feeling, except that one guy's particular question. Everybody uses the same question.
Exactly.
Okay.
So that is just the beginning. When we start to define what it is, when we're getting a theoretical understanding of it, that's the beginning of the tool construction process.
Okay. Okay, I'll send you this questionnaires this week.
Yes,
Okay.
please. Yeah, all right. I'll take a look at it. So I think we're done with class today. We will discuss about how Mr. is going to go ahead and take class. But just, I think I've left out an assignment on reliability. I forgot to post it in Google Classroom, I believe. So it's still in my draft in Google Classroom. So I will post the assignment on test retest reliability and the data collection assignment for you on the value questionnaire developed by Mr. Roy. Sorry, Dr. Roy. So we'll just post these two on the Google Classroom right now, so that you all can finish the assignment in your leisure time.
Sure. Okay. Thank
Awesome.
you.
Have a good night.
Good night.
Thank
Bye.
you so much.